Okay, question 4. We have a sample which contains these 4 ions in a solution, and out of that we have to somehow get just the iodide ions in the form of some kind of solid which we can produce as a pure sample. So what we need are reactions which we can use, which will distinguish between these. You know these reactions particularly as tests for these ions, and you've just got to use those reactions but just change the way you think about them, because we're obviously not looking to test for them, we're looking to use those same reactions to get rid of these things so that we can just leave the iodide ions. So the obvious place to start is with the carbonate, because obviously these 3 are closely related, whereas that's very different, so that's the most straightforward one to get rid of. And what you should know about carbonates, probably the only thing really you know about carbonates, is that they react with acids to form a salt and carbon dioxide and water. So if we choose a suitable acid, we can get rid of the carbonate in the form of CO2 and form instead a salt with the negative ion that comes from the acid. And the one to use is nitrate. Just like you do in the tests, remember you use nitric acid, barium nitrate, because nitrate is an ion that loves being in solution, so it doesn't tend to precipitate out, and precipitation is what we're going to use to get these ones. So if we first of all add dilute nitric acid, because you know that that will react with these and it will leave those ones alone, so you say that it reacts with carbonate, and hopefully you can just write the ionic equation down for that straight away, because you know that what happens is that the carbonate ion reacts with the H plus ions from the acid, and that combination you can see easily is what gives you the salt plus water and carbon dioxide. Okay, so the nitrate ions don't appear in the ionic equation because they stay in solution. That's the important thing. And whatever positive ions may be there, we don't know, but they don't appear either. So we just get rid of the carbonate and turn it into CO2 and water. So we say that this removes carbonate. Okay, so job done there. And yes, we've now got nitrate ions in solution, but that's not a problem, as I say, because if we're going to do precipitation, they're going to stay in solution. So then you think, right, okay, we've now got chloride, bromide and iodide, and hopefully now you think, oh yes, silver nitrate will precipitate all of those out. And then if you remember the tricks with ammonia, you can begin to see how this is going to work, that having precipitated them all out, we can get some of them to redissolve, but not others. Okay, so let's do that. So the second step is to add silver nitrate solution, which is AgNO3. And what that does is precipitates chloride, bromide and iodide. So all of those ions will precipitate out. And you probably don't need to write all of the equations because they're all basically the same. So chloride ions, for example, meet the silver ions and form solid silver chloride. And you know, you could write the other 2 out if you want, but obviously it will just have bromide and iodide doing the same thing. So that's the second step. So now we have, this gives a solid mixture of AgCl, AgBr and AgI. So if you didn't know about the trick with ammonia, that wouldn't be particularly helpful, but the point is that you do, and you know that if we add concentrated aqueous ammonia, that will dissolve silver chloride and silver bromide, but not silver iodide. And that's the confirmatory test that you need to learn for the halide ions. So that will redissolve AgCl and AgBr. But silver iodide won't redissolve in ammonia no matter how concentrated it is, but leaves solid silver iodide. So now we're almost there, but that's not a pure sample, okay, because it's still floating around in the solution with the ammonia and all these other things. So you need to finally add on to that, how do you get from this mixture the pure solid silver iodide? So the fourth step is that you filter off the solid, and then always when you have a filtration step, the problem is that there'll be some solution still sticking to it, and obviously the stuff dissolved in that needs to be got rid of. So you wash with something it's not going to dissolve in, and silver iodide is obviously insoluble in water, so wash with distilled water. And that will get rid of the solution that's sticking to the silver iodide, and then you dry it, and that will leave you pure silver iodide solid. Okay, so as I say, the thing about that question is that it's not asking you something you will have prepared in advance, but all you needed was to think how you could apply reactions you have learnt, the ones you've learnt for the qualitative analysis, and how you could apply them to a preparative method. So it's not a big leap, and it's the kind of lateral thinking that you need to be able to do.